Genau. Ja. Tena नहीं बोल रहे यार अंदर होना
Hey, hi, hello everyone. So, are you guys able to hear me? Is it audible?
Yes, Shraddha, it was something.
Okay. Okay, then I'll start with signal systems and then we can move ahead. So, I'll just present my screen now. And in between, if somebody has a doubt, you can just let me know. And then we can move ahead. So, I'll just present my screen now. And in between, if somebody has a doubt, you can just let me know. Okay, so can you just mute yourself over there? Yeah. Okay. Okay, so I'll just go through the signal system. So this is one of your diploma level courses. Okay, so there's some prerequisite for the signal system. I guess this is easy. If I hope everybody who would be opting for the signal system would have finished your EC course in the foundation level itself, and then only you can opt it for the signal system course. Okay, and the video and lectures, the video that we'll be getting that will be from Professor Lakshmi Narasimhan, sir. And the videos lectures mostly every week will be having some 2 to 3 hours of content. Along with that, we'll be having live session also. So 3 live sessions by the instructor and then some live session from the TAs also will be there. Apart from the three, there will be some MATLAB assignments also that you'll have to do. So 5 assignments will be there for the MATLAB. Every second week we'll be getting one. So that will start from week 4. Okay, so that is there. The content, okay, one second. So it's there already. Yeah. So we'll start with, so the content will be something like, we'll start with the basic manipulation of signals and all. In the starting weeks, we'll be learning about some of the signals also, the delta function, the basic unit RAM functions and all. And then in the coming weeks and all, we'll be learning about some operation on the signal itself, like the time shifting, scaling, all those stuffs we'll be learning. We'll be learning about the phasers also. Many of you would have already studied those phasers in EC course also, and a bit about that in ESTC also. So we'll be going through that phasers again, because that generally helps us in many solving many of the circuit courses also, and even in the signals also. We'll see how does that help. Okay, so whenever in the EC you would have learned about whenever you are dealing with a circuit that contains like capacitor or inductor, right? Storing energy, storing devices. So there you can, with the help of phases and all, you can get to know about which one is leading and lagging amount. So here also you'll be learning a bit about the phases again. And then again, the manipulation of signals, like we'll be learning about the different types of signals, like odd, even, and then orthogonal signals, symmetrical, like conjugate symmetrical signals, and then periodic power signals, energy signal. So more or less in the starting 4 week before the quiz one, we'll be just learning about how you are going to deal with the signals. Okay, so all the operations on signal, different types of signals. Okay, so that we'll be learning in the starting 4 weeks. Then the next 3 to 4 weeks, we'll be learning. Can you please mute yourself, Gaurav Verma? Okay. In the next 4 weeks, up to quiz two, we'll be learning more or less about the systems. Okay. So first, we'll be learning about the signals, and then system, different types of system and their properties. We'll be learning, like a causal system or a memoryless memory system, invertible, stable, or LTI. LTI is one of the most important that from now onwards, whenever you are dealing with the circuit courses and all, those generally contains those are the like LTI system that you'll be learning. And then we'll be learning about
Second. Is it audible? Okay, yeah. Okay. So I was there in the week 5 and 6. So we'll be learning about the systems, the different types of system, their properties and all, like the causal or memory or memoryless or invertible stable system. And then I was talking about LTI system. Okay. Linear time invariant system. We'll be learning about those, and that keep on coming. Like whenever you're dealing with the circuits and all, mostly those are LTI system that you deal with. And then a bit about the convolution we'll be learning. Okay, and then we'll jump to the Fourier analysis and all. Okay, so we'll be dealing with how to deal with the periodic signals, non-periodic signals with the help of the Fourier analysis, Fourier series and all, and the properties of those. And one more thing, so in the signals, we'll just be learning about the continuous signals. Okay, in the coming courses, DSP and all, we'll be learning about the discrete signals and all. But here in signal system, we'll just be learning about the continuous signals. Okay. And in the last 3 4 weeks, again, you'll be learning about the different types of transform, like the Laplace, Fourier transforms. You'll be dealing with like different type of a circuit. Like if you have a circuit like that contains resistor and a capacitor, that generally can be a form of a low pass filter or a high pass filter or a band pass filter, right? So there, how will you utilize the Fourier transform or the Laplace transform and not? Okay, so this is what mostly in the last 4 week you'll be dealing with. So in the starting 4 week, I told you signals and then systems and then the different type of transforms. This is what the whole syllabus is for the signal systems. Okay, in the coming courses and all, again, you'll be learning about the discrete signals and all. I hope this is clear. So as of now, what I said, like you'll be getting 2 hours of 2 or 3 hours of lecture per week. So this whole week, the whole content will be of the 12 weeks, and apart from that, we'll be helping you out. I'll be there along with Lavanya. Will be there for assisting you for the most of the session. Okay, and then we'll be having some TAs also to help you out for the whole term. Okay. Apart from that, so MATLAB I was talking about, some assignments you'll be getting for the MATLAB also. You'll be having some sessions also. So we'll be having, I guess, so the MATLAB assignments and all will start from 4th week, and we'll start having some sessions also regarding the MATLAB. We'll start from very basic things, and that will contains like 5% of the whole marks of your signal system. Okay, so that is how it is going to be. Okay. Yeah, any questions? If anybody has, you can just let me know. You can ask.
Can you show the first slide?
Yeah,
No, I mean second one.
yeah.
So our in-person quizzes and okay, okay, fine. No lab is there, no?
No, as of now, there's no lab, but we are working on that because earlier, before last term, there was a lab,
Huh.
but as of
It
now,
was
it's
5 credit course. Now it's 4 credit course. Yeah.
yeah. So as of now, there's no lab as such, but yeah. So there is a
So
separate lab that has been done, combining DSP and signal system.
yeah,
That
yeah, yeah.
we'll be dealing with that later part. But as of now, in the signal particularly, there's no lab as such.
This is now totally theory 4 credit course, but we do
Yeah,
have this weekly online MATLAB. No?
yeah, weekly, like
Total,
bi-weekly.
how
Yeah.
many exercises would be there?
Bi-weekly it will be there. It'll start from fourth week, so we'll be having some five uh, MATLAB assignments.
Okay, fine. And do you have any update about our 2 credit that
Lab.
signal? Yeah, the 2 credit lab course.
Yeah. So regarding that, we'll be like coming up with that. But as of now, we have like it's not been decided yet. But yeah,
Okay, fine.
yeah. But it will be coming, but not this term for sure. Not along with this signal. Yeah.
Okay.
Anybody has any other doubt?
For which other courses next we'll be having labs?
For which of the courses we'll be having lab? This is what you're asking?
Yeah. For an upcoming whatever courses like suppose in signals like it was 5 credit or now 4 credit. Only for signals it has been done, or for some other
No,
courses
no.
also it has
For
been done.
signal last time also there was no lab as such. Before
Yeah,
that
yeah.
it was a lab. Yeah.
Last time it was done. For now this term some changes we have means it have the changes been done from other any other courses.
No, no. For signal, what happened is now we'll be having a attached lab. So after like for signals and DSP, we'll be having a single lab. Okay. So that is what that has been done. For the last time also there was no lab. This time also there will not be any lab for signals. For all other courses, it's same as before.
No changes.
Yeah.
Okay, sir.
Hmm.
Maharaj, you have raised your hand. Can you please unmute and ask your question?
Yes, sir. I am finished my foundation level. Till now, I am not getting any email. I finished or not. How to join the diploma course?
So those mails and all, yeah. Once the score is out, you'll be getting the options. So you have finished like the foundation. I mean, the whole 1 year, the foundation
Yeah,
course, right?
yeah. All the courses I finished. Last only one course is missing. I finished that the OPP Linux. But till now, I am not getting any email. I finished or
Yeah.
not.
You'll be
I
getting
passed or not.
once the scores and all is out, then you'll be getting the options to go and select for the further courses and all. So as of now, we'll be releasing the scores and all in the coming 1 or 2 days, and after that, you'll be getting a chance to register for the other courses for the maybe for the diploma courses. Right?
Oh, okay, thank you.
Yeah. So in the coming 2-3 days, it will be out. Yeah.
Okay, thank you.
Okay. Thanks. Yeah. Next.
Shakshu, can you please
Uh,
unmute and ask?
yeah. So basically, I completed my foundation this term, the May term. For the diploma, is there any minimum number of courses that we're supposed to do within a year? Because I'm planning to take a year break before I start with my diploma. So how feasible is that?
No. So you have already finished your foundation and you
Yeah, I
want to
just
take a break,
a
right?
year break at least before I start off with diploma.
That is feasible. Like you can, that's up to you. You can, there is a maximum number of duration that you'll have to follow. I guess that is 6 or 8 years. I'm not sure about that. That you can
That
check it.
6 or 8 years is for the entire degree, right?
Yeah, that is for the entire degree. So you can take a break and then come again. So there's no issue in that. Yeah.
Yeah. Okay. Thank you.
And
Actually, if you like to add, please, I would like to add that you can please put the same query to the support team also regarding this to get a clear cut answers.
Okay, sir.
Yeah.
Thank you.
Sir, hello.
Yes.
Like for this term for control engineering, who will be the any assistant like?
Yeah, for control engineering, right? You're talking about.
Yeah.
So after this, the control engineering persons will be going through. So he
Oh,
might.
okay, sir.
Yeah.
Yes, sir.
Okay, so we can go to the next course then, Prabhu. We can go to the next one. Thank you.
Yeah. Thank you, sir. 50% is done.
Hello.
Yeah.
For this current course, what is it told that signal system, all that? What other just videos will be released and the MATLAB section will be there. So any specific books we need to follow, go through all that?
Sure. Can you please give me the series topics for this course?
Hello.
Yeah. So we'll be telling you about some books also, SOM series books. Normally you can follow, but yeah. So there are some books. Those will be notifying in the starting in the first sessions and all. Maybe that you can follow. But as of now, maybe the prof generally will tell you regarding like the SOM series book you can follow for the signal system. Right?
And
So more or less, whatever the graded assignment, practice assignment we give, I guess that is more than sufficient to practice and all, because uh, there's not like we generally give like you'll be having some activity questions, and each week contains some 5 to 6 videos, and each videos will be having some 5 questions. Okay, so altogether you'll be having 30 questions, and then practice assignment will be having some 20-30, and then graded assignment some 12-15. So each week you'll be having some 70 to 75 questions. So I don't think so in a week of time, like say after like in a 7 days, I don't think so we'll be able to manage and practice more than that number of questions. Even though if somebody needs maybe we can share some more files or something just for practice sake. Yeah.
Okay.
But
And
yeah, go ahead.
yeah, okay. And as per your experience with the earlier batches, I think 2 or 3 batches have gone through the diploma level for the signal and system core there. So what you can suggest, it was to follow the things to have good go through this subject and have good experience and all that.
Yeah, see, as of now, mostly see this signal system is one of the very simple courses of core electronics courses. Okay, so here you don't have to go here and there. More than like the lectures itself is more than sufficient to solve like to get the like basic clarity about the concepts. Okay, and
Right.
follow like the most important thing is to attend the live sessions also as much as you can.
Okay.
Okay, and then use as much as the discourse access, like discussion forum and all, to have to put your doubts. Like as of now, what I am seeing is in mostly in the electronics, nobody generally asks the doubt itself, right? In the
No.
discourse forum. So I'll have to like so that discussion for like discourse forum has been made for the doubts and all only, and I
Right.
don't think so many people generally ask the doubts. And if you just
Okay.
ask the like, if people start asking, let's say like, then there will be a repository for the doubts itself. So that'll be good. Like you can come up with any other questions also apart from the graded or practice or anything. So
Right.
that is a good habit to have. Even though we'll be having a G space also, I'll be creating. So that also for just for the interaction between the instructor and the students. So that will be also to make everything smoother and all. So we'll be having a G space group also. You can put your doubts and everything there also. Small doubt also you can ask. Like there's no problem in that. Yeah. So that is how
Okay.
the best practice is to attend the at least the lectures, and then attend the sessions to just clarify if you have any doubts. And after that also, if you have, then put it in the discourse or maybe in the G space to clarify every doubt. And the bare minimum that we are expecting is to at least watch the lectures and then practice the practice assignment and the. So after every lecture that you watch, right, there are some 3-4 questions based on the lecture itself, just to test whether you have watched the lectures nicely or not. Practice that, and then practice the assignment question, practice assignments. That is more than sufficient for anybody to to get a good idea about the signal system.
Okay, sir. Okay, thanks a lot. Thanks for the words.
Yeah, thank you.
Vishal, shall I continue?
Yeah, Prabhu.
Okay. Just a minute. Shall I screen first? I hope you can see my screen.
Yeah, visible.
Yeah. Okay. So I'm Prabhuram, and I'm a purpose instructor for the digital system design. The fourth faculty is Professor Nathan Chandrasekhar. And along with me, this time, Professor Sujoy is also one of the persons handling this as a course instructor. And this course is mainly meant for how you design and verify your digital circuits. The primary prerequisite for this course, you already know about it, the basic business system summary. And the extension of that only we're going to include it here. And we in this particular course, we give some small, we just educate you in the form of Verilog coding. And we try to infuse all the hardware core modules, what are the hardware designs, what are the things you have done so far in the basic visual system design, basic systems that is going to execute in the with the help of Verilog coding here. And this the learning outcome from this particular course is that you can, I hope you can able to model your digital circuit with the help of Verilog coding or system Verilog coding. Primarily, you're going to use Verilog coding as a system Verilog. And for installation, we can, there is no need to externally install software. Sorry?
Hello?
Yeah?
Sorry to interrupt, but you are going very fast, sir.
Okay. Well,
Sorry
so
for
this
interrupting.
particular okay, let me slow down. So this particular course, what is the purpose? In this particular course, you will teach you what is Verilog coding, and the primary thing is not to know how to write Verilog code. The only thing is how to use this Verilog code. So we are not expecting you to write all the syntax
So
need to
what
be.
interface are we using for Verilog?
Uh,
ID
yeah,
model
that
or
is
something?
the specific Vivado software is used when you are doing for lab component, but for the practice purpose, we'll use online software itself. That is EDA Playground.
EDF.
EDA Playground.
Okay, sir.
There's online where you can able to use this particular to understand and explain emphasize yourself more in that of it. So the learning outcome from here, this particular course is we hope that we're going to design your basic CPU itself, and also how the system on chip or what is the theory of behind the system on chip components, and we'll simulate all things. And in this, as usual, we have 12 weeks content. Out of 12 weeks content, the first 3 weeks content is mainly meant for knowing the Verilog coding and the basics of digital system. We just recap all the topics which is there discussed in the basic digital system. And the same component going to implement using we just study about the Verilog coding. How to write the Verilog code for combination circuit as well as sequential circuit. All the things we can study in the first 3 weeks. From the fourth week to fifth week, we're going to discuss something about the finite state machine model. And anyhow, in this particular week onwards, fourth week onwards, we are not touch in depth of Verilog coding, but we assume that we are practice much better than before with the help of other basic circuits. So we just go with the higher level of how to design the FSM model. I hope you know about FSM model. You are studying in basic digital system. I think somebody is. Can you please mute yourself? Yeah, thanks. Yeah. So with the FSM model, from the week 4 to week 6, we'll discuss about the FSM model and how to design hierarchical and what are the memory components are there. And from week 7 to week 8, we discuss a CPU architecture. That in that CPU, we discuss about what is one of the very important topic, component called the arithmetic logic unit, and also one of the decoder circuit which decodes your instructions. If that is how you do it, that things we're going to study from week 7 to week 8. From week 10 to 12, so there is 1 week is left for us for recapping all these first to 1 to 8 component. Hence, week 9 is not discussed here. It's just a recapping of all the things. Week 10 to 12, again, we just go ahead with toward the direction of system on chip and theory behind it. And the tools we are using Verilog HDR, and as for this language, we use the online simulation. iCaris tool, if you like, you can install your iCaris tool, which is a Verilog where it can able to simulate yourself in your local system. Or otherwise, you can use, I already mentioned it, there is several open source tool, out of which we are I used to execute in the EDA playground. So what are the things we are expecting you have is you have to, I mean, you have to supposed to right now how to create a test bench, because we will teach you all the things, test bench and all, and finance design of finance state machine models. And assessment modules we have as usual for 12 assignment, weekly assignment, quiz 1, quiz 2, and end term that is conducted every 4 weeks. And at quiz 1 important dates. I hope you will get details on in the grading document. And the T-score for the theory part is 0.1% of GA, I mean 10% from the GA, and there is GRPA calculation that where we can give the just 3 practical assignment that you have to supposed to be submit in the portal itself before the deadline. And similarly, we have another 4 practical similar kind of assignment, which is somewhat higher level, which we called as a weekly lab assignment, and that you used for the digital system lab part. So average of this only will make you to take the eligibility for your writing your attending the digital system lab part. Basically, we need at least average of above 40% from all 4 weeks lab assignment component. And the dates. Yeah.
Sorry for interrupting. This weekly lab assignment will be like face to face, or how is it?
Face to face in a sense. I couldn't. Could you please
You
elaborate?
like on lab assignments you need to submit, right? That will be like online, like it will be conducted like face to face or like virtual meeting
No,
or like
not face
like
to
live
face.
version.
We will just put we'll just assign the task to you as like how the other for like
Okay, I got it. Got it. I got it.
yeah. So you have to submit before the deadline. You can use
Understood.
supporting, but don't. Please follow the honor of code. Okay, that's it. So, any questions?
So that week 10 you told system integration, right? The system
Yeah.
integration and something was there. And SOC design. This system integration means like basically what integration, like chip level designing testing, or how you're saying it? Can you just
So,
verify this?
yeah. Basically, we are designing the CPU model. In the CPU model, we are designing ALU model and instruction decoder model. All are separately is there, right? And your all the things is need to be integrated along with the predefined module. Say, for example, I don't want to use my own multiplier. Maybe I can use a DSP multiplier. Some of the IP cores, which is already standard IP cores will be there. So all these things can be can be integrated as a system on chip, as a single chip.
Okay, sir.
Theory basis only. It's all theory based only.
Understood, sir.
And for that case, what are the supporting? How you if I integrate, how do I how do I validate? How do you verify it? What are the internal buses are used for communicating these things? How I'm going to use some AXI bus is there something. You're going to study some all the things in the particular week.
Yes, sir. Thank you.
Yeah. Any other question?
No, sir.
So primarily, we need prerequisite is very hard because the basic digital system design. You please, if you what are the things you have studied, you please recap also. Anyhow, in the first week we're going to discuss the same thing, but somewhat faster in nature. Within the 1 week, 2 hours content, it will be there, and in the live session also we'll discuss most of the problems. If you have any question, please rise up at that time on every instant itself. As previously Vishal said, please we have the discussion forum. Use the discussion forum for all the any query clarification. Please use the discussion forum, and also we have GSpace. For me, I just consider the GSpace for any emergency purpose. Like if you if the discussion forum we will unable to answer, we are getting that you're not able to get the result immediately. Maybe you can post your queries in that particular GSpace itself. Because what are the queries we have is supposed to be in repository, but in the GSpace it's not recording. That's what. Okay. Okay, somebody's raised question in chat. I think so. Just a minute.
So for this, we need any hardware, any module we may require, like a component, something we need for this course.
No need to buy. No need to buy any component, but we will give you a component for here. There is a FPGA Bitping Z1 board we will have here. So during that time, when you come to our in-person lab, you supposed to implement what are the things you are so far generated in the online itself. That is generating bitstream file, something. So okay, some of the executable file is there, and you are generated in the software itself, in the in your system itself. You going to implement in the hardware level, so that you can do in the lab part. That part we will issue it to you when you are coming for in the campus.
Okay, sir.
Okay, if you're willing to buy a FPGA board on yourself also, but it's too costly. But if you're willing to practice, there is no blocking. You can utilize that if you like.
Understood, sir.
Yeah. Purnima, can you please unmute and ask me the question? Um, uh, you mean what hardware? Do you mean that you want to purchase the hardware component in such a way you are asking? For DSD, there is no need to buy extra. I mean, you don't want to personally need to buy the hardware component, but if you wish, you can buy. If you wish. I think there is no course having such a hardware component based. Am I right, Rishon? Are you there? Jennifer?
Yes, sir.
Is there any hardware components you want to buy for the other diploma level course? But in DSD, there is no hardware component.
Sir, electronics
Not to
lab,
purchase,
they want
right?
to take me. Electronics lab. Electronics lab.
No, diploma level, I'm asking.
Technical no sure, sir.
Yeah. Thanks a lot, ma'am. I hope, Fatima, we are cleared the doubt.
Yes, sir.
Thank you. So for the diploma level, I think we don't require any hardware component need not be purchased by your side. We will issue a hardware component for the DSD when you come to the in-person lab. Okay, that's. So I think we can move to other course. Tony sir, are you ready? Ankit?
Okay.
Yeah.
So can you start with control engineering?
Second, I'll just confirm the person is not able. Victoria, ma'am? Okay, I'll just talk. Let's. So Tony said, please continue. I'll just confirm the person who's breaking the control. Just wait for some moment. Tony said, please continue, sir.
Okay, so who is going to present next? Okay, Tony, fine.
Okay, good evening. I hope you can hear me. So I am here to present about this diploma course, that is EE3101, that is digital signal processing. So it is a 4-credit course. It is a diploma level course. And the prerequisite for this particular course is signals and systems. The professor who will be handling this, the online sessions, I mean, the recorded sessions are done by David sir, and myself and Lavanya will be the course instructors for this particular course. So again, the syllabus is divided into 12 weeks. So week 1 to 4, usually we do for quiz 1. So in week 1 to 2, you have general introduction to sampling, then review of signals and systems. So in signals and systems, basically you might have studied about continuous time signals. So here we will be discussing about discrete time signals, the operations on discrete time signals, then basic system properties, okay, and then LTI systems, impulse response and convolution will be dealt in week 1 and 2. In week 3 to 4, we will be discussing about sampling, how sampling is done and how it is affecting the time domain, everything, reconstruction, aliasing, all the effects will be dealt in week 3 and 4. Then in week 5, 6, we will be dealing with discrete time Fourier transform, just like your continuous time Fourier transform in continuous time systems, you will be having here discrete time Fourier transform. Then the properties of discrete time Fourier transforms will be dealt. Then in week 7 and 8, we'll be discussing about Z transforms. Similarly, the properties of Z transform, the ROC, all those will be discussed in detail in week 7 and 8. So for quiz 2, you will be having portions from week 5, 6, 7, 8. Then week 9 to 12, you have the frequency domain analysis of LTI systems. You have the design of FIR filters. Okay, only FIR filters will be dealt in this particular course. Then types of FIR filters will be also discussed. Then week 11 and 12, you have discrete Fourier transform. How discrete Fourier transform is evaluated using fast Fourier transform method algorithm. And then the properties of DFT will also be discussed in detail. And for end-term, the quiz, the course syllabus portions will be from week 1 to 12. Okay, these are the prescribed books. First one, the textbook is LNV Open Discrete Time Signal Processing. Then second one is Tarun Kerawat Digital Signal Processing. And apart from that, these are the other books that Professor will be following, that is Proacus and then Sanjit K. Mitra. Okay, so these are the textbooks that will be. Mainly, we will be following LNV Open. Okay, so quiz 1, as you know, it has 2 quizzes and 1 end-term exam. Quiz 1, October 26th, quiz 2, November 23rd. Okay, and these are the eligibility and all. And of course, it has a lab part. Okay, the lab part has 15 marks. Remaining marks is from the theory part itself. Okay, so lab part, it has 10 marks for the lab experiments that you are doing and 5 marks for a small viva sort of exam that you will be conducting. So these are the deadlines for the experiments. Okay, and then you have, these are the course outcomes. So after successful completion of the course, student is supposed to be able to work with all types of discrete time signals and apply DSD techniques on them, use time and frequency domain methods to analyze discrete time signals and systems, understand the process of sampling and reconstruction, and design digital filters for different applications. So 2 live sessions per week will be there for the theory part, and 1 live session will be there for the lab part. These are the experiments usually we do. Minimum 8 will be there. Apart from that, we will be giving more exercises also in MATLAB. All these experiments will be done using MATLAB Grader. Okay, everything, we will be adding the students into MATLAB Grader, and from there, you will be able to access the experiments and complete the experiments. Okay, so this is about digital signal processing. If you have any queries, please ask.
Okay. Yeah. Can you just okay.
Very good evening to all. Basically, orientation related to the analog electron system. The faculty of this particular course is Shanti Pawan sir and P.K. Sundarajan sir. And we are three instructors, myself, Dr. Ankit Agarwal, along with the Vasundhara and Saswati. So basically, the course highlight, this particular course will be distributed in two parts. First, we go with the operation amplifier, then we implement that operation amplifier for the practical application and design a system. Okay, so week 1 to 7 is related to the operation amplifier. Then after that, we use that particular operation amplifier for practical application to design a system. And the system we discuss here is the Bluetooth headset system. Okay, in the Bluetooth headset system, we have multiple subsystems.
Lectures.
Yeah.
Those are the like LTI system, and then only you can
Others, could you please mute yourself?
stable system that because earlier for signal what happened the foundation follow I guess sessions.
Hello.
Earlier batches, I think 2 or 3 batches have gone through the diploma level.
Kindly mute yourself.
And each videos will be having some 5 questions. Okay, so altogether you'll be having 30 questions, and then practice assignment will be having some 20-30, and then graded assignment some 12-15. So each week you'll be having some 70 to 75 questions.
Gayatri.
In a week of time, like say after like.
So initially we start with the operation amplifier. First we start with the analog electronics. Then we go with the operation amplifier. In this operation amplifier, we discuss the dual supply operation as well as the single supply operation amplifier. Okay, after that, we use that operation amplifier for some particular application, that is a summer integrator, differentiators. Then we design a filter. In the filter part, we discuss a single order, first order filter, second order filter, low pass, band pass, high pass filters. We discuss in this particularly that are the application of operation amplifier. Now we switch to the Bluetooth headset subsystem system. In this Bluetooth headset system, the main subsystem is the power management. How we manage the power. Okay, so for that one, we discuss the power management system, linear and switching regulators. So these are the week 1 to 11 content we cover. Operation amplifier part, if you see, there are 4 particular topics, so that will be covering from week 1 to week 7. And week 8, 9, 10, 11 is related to the application of operation amplifier. That will be covered by the P.K. Sundarajan sir. And first 4 will be covered by the Shanti Pawan. If we go with the books related to the operation amplifier, so we cover 3 books. One is the Microelectronic Circuits by Sadra and Smith, Electronic Circuit Analysis and Designing by the Donald A. Nieman, and Microelectronic Circuit Analysis and Design by Donald A. Nieman. These are the 3 books related to the operation amplifier. Okay, for the Bluetooth handset, the Professor P.K. Sundarajan, basically, he cover one, but C30 is a one Bluetooth device, so he will cover on that one. Okay, so they will discuss with some data sheets related to that particular component we are using for a Bluetooth subsystem. Okay, if we go with the grading scheme, so the grading scheme is the 0.1% of the graded assignments. Okay, then final is 0.6, and the maximum of quiz 1, quiz 2. There are the 2 particularly scheme. Either if we appear in the quiz 1 or quiz 2, so we cover the 0.6 final plus 0.2 of maximum quiz 1, quiz 2. And if we appear in both quizzes, so 0.4 of the final plus 0.2 of the quiz 1 and 0.3 for the quiz 2. Which one is the maximum? We will consider that one and add with 0.5 for the grade result. Now, if we are talking about the learning outcomes, so basically we understand about the learning fundamental concept about analog system, then we apply that particular concept for the real world applications. If you have any doubt related to that one, you can ask.
If you have any doubt, you please raise your hands. I can unmute you.
Okay, thank you.
Hello, sir.
Yes.
Hello, sir.
Yeah. This.
Good evening, sir.
Lavanya, good evening. Yeah, one
Now,
second. Yeah. Lavanya, can you please unmute yourself?
yeah, okay, fine.
Yeah. So,
Sir,
yes,
yesterday
others.
mail received only on ESTC, sir. Actually, I take Linux, but no mail comes from this till now, sir.
Come again. What's your question? What's your query?
So yesterday mail received only ESTC course, sir. Actually, I take Linux, but no mail comes to from this till now, sir.
Score.
You,
When the
you
score will be
applied for
released. You are
What,
asking
sir?
about the score? You are asking about the score?
No,
you
sir.
are
Actually,
Final
I'm
applying
score.
for
taking
lab.
Linux course, sir. Hello, sir.
Can you please answer for this?
I'm saying you are asking about the course or basically the registration?
Course, sir. Actually, I'm taking.
No. Okay, you are going to take in the September term. That is.
Yes, sir. Yes, sir.
But
Tomorrow.
but you are taking. You are asking about the course registration or the about the labs you want. For the lab part, you are asking, or basically for the course enrollment you are asking?
Lab part, sir. Linux lab.
Okay. Okay. So better that you can. There is one G space or basically created for the Linux lab, no? So better that you can ask your query with them. Who is the course instructor for that Linux lab?
Yes, sir.
So better that you can write a mail to the support team and your instructor also, and you check your eligibility also, if you are eligible or not.
Eligible,
If any
sir.
eligible, so yes,
Yeah.
drop a mail to the support team as well as the instructor.
Yeah, sure, sir. Sir, in this meeting, Linux or ESTC?
That is for the new courses that will be started from the September.
ESTC lab is asking about the lab. But this is not a lab. This is a theory course, sir. The orientation.
Okay.
No, the
I
diploma level.
forgot. I thought this is lab course tomorrow for.
No,
not
for
that.
Yeah, sure. Thank you, sir.
Okay. Lavanya, ma'am, you can proceed now.
Yeah, thank you. So is my screen visible?
Yes.
Okay. So good afternoon, everyone. So I'm Lavanya. So we will have a brief introduction to the course Maths for Electronics 2. So this course, the course faculty is Dr. Andrew Tangraj. He is a professor in Electrical Engineering Department, IIT Madras. So all the video lectures are provided by him. And for the live sessions, the course instructors are myself, Lavanya, and Prerak Deep. So we both will be handling the live sessions. And apart from the course instructors, we also have a TA session mainly to guide the students in solving problems. So the theory part, whatever questions you have, the students can ask the course instructors also. So if you have doubts in the problems, also you can ask. But the TA sessions are specifically arranged so that the students can use them to practice or get their doubts solved in problem solving. Okay. And the structure of the course is as follows. So in the first 3 weeks, you can see that the most of the course contents, first of all, is from linear algebra. And the first 3 weeks you can see is from basic linear algebra only. So here the basic linear algebra along with some geometrical interpretations are also there. And then slowly we move on to little next level of linear algebra. Then we diagonalization. So this diagonalization is kind of the beginning where we can start looking at more application parts. And to understand more about this diagonalization, we also have introduced matrix algebra, inverse, and determinants. And these are the fundamentals which we will be using for the next set of weeks. So Once we are thorough with the first 6 weeks, the next weeks are going to be easier because they are going to be mainly based on the first few weeks. So here you see that the first 2 weeks, you can see week 7 and week 8 are mostly based on the things which are covered from week 1 to 6. Okay, and then this week 9 and 10 contents, they are more geometric, and here we also have some applications also. So all these things, you have some interpretation using GeoGebra applications, and also at the end of this course also you have all these techniques done using computers. So linear algebra using computers, we have a separate section where all this is done using some basic MATLAB programming. Okay. And in the last 2 sections, you see that we are advanced spectral theorems, and you also have graph theory is included. So in graph theory, we are not going to look into the details of graph theory, but here we will just use how circuits are represented using graphs, and how these graphs we can study using linear algebra. So how they can be represented as matrices, and from matrices, how can we interpret the graphs. So some things about that will be covered here. And in the last, we will be looking at correlation covariance matrices and more of this Fourier basis and discrete Fourier transforms. So you can see that the level of intensity is gradually increasing. So the first 6 weeks are a little lighter comparing to week 7 and 12. So, but this once week 1 to 6 are strong, you are strong enough in week 1 to 6. I guess week 7 to 12 will be easier for you to understand the concepts. Okay, and you see that we have activity questions, practice assignments, and graded assignments. So in the TA session, mainly you will be solving the activity questions and practice assignments, based on which you can solve the graded assignments. And you can ask your doubts. We will have anyway GSpace is there to ask your doubts, and also you can also ask your doubts in discourse forum as well. And we are having, as usual, 2 quizzes and an enter, right? And so you have like for lectures, you will be having approximately 2.5 hours per week, and this is the expected effort from your side for a successful completion of the course. And in 1 week, we will have 3 sessions. So we will have 2 sessions from instructors, which will be 2 hours each, and 1 TA session. And these timings are not really like fixed. So suppose you have more doubts. So based on the students' demand, we can extend the session if required. Okay. And so yeah, the primary study materials are from videos and assignments, but yeah, this is a standard textbook which can be used as a reference for this particular course. Thank you. So if you have any questions, please ask.
If you have any queries, please raise your hand.
Sir,
Yes.
so for the control engineering, can someone speak?
Yeah, I just wait for him to join. He said I join by 5 o'clock. Let's wait for 5. Just 1 more minute. If it didn't update also, I'll just update you.
Joshua, can you start?
Okay. Yes. Uh, am I audible? Can? So I'm audible, right? Okay.
Yes.
Okay. So I will be talking about the course named titled Electronic Product Design (EPD), which is offered in the degree program. So this course is taken by Professor L. Umanand. He is a professor here in the Department of Electronic Systems Engineering in IISc Bangalore. So he is the one who's offering the course, and my name is Joshua. I am a PhD student working under Professor Umanand, and I will be the teaching assistant for this course. So I am audible, right? In case my voice cuts out, and just give me a feedback. Okay. So yeah. So I'll continue. So this course, as you all know, is offered to the degree students. So there are a lot of prerequisites for this course, and many of those prerequisites will be covered as you go through the foundation or the diploma programs. So this course is it's where a lot of things that we have studied before comes together, and we talk about building an actual system. So one of the examples we build is a power supply. So we talk about how to design a power supply for various applications. You know, so when designing a power supply, then we have to know about the control aspects of things. So that you would have learned in that is there in control systems course. So you need to know a lot about how to design a controller. Then we have a lot of analog signal processing, digital signal processing, because we need to sense voltage, current, and then we need to give them to our controllers. And so then some basic knowledge about microcontrollers. So some programming of some controllers are required. So basically, in this course, we cover all of these things together, because we have to bring all of these blocks together to ultimately build a final system, an actual working product. So that is the main focus of this course. So we will be more design oriented. So sir also, if you go through the lectures also, you will understand where we'll be talking about design, the design equations, and how to design a particular system. uh, and as of now, those who are new, and if you want for more idea, you can actually check the YouTube channel of this electronic systems BS program, their YouTube channel. So all the courses, all the lectures have been uploaded in that. We have for the past run, we have completed now one batch, and so in if you go through that lectures also, you will get a deeper understanding of what it is about. So this is also as similar to all other courses. So this is also 12 weeks, 12 weeks, and uh, so this 12 weeks, we'll have 2 quizzes and a final exam, and also there'll be a small project. That project is also based on PCB design. So our end goal is to give you an exposure of how an actual circuit development process takes place from the designing stage to we will do some simulations. So that you will have some softwares for doing simulations, and then some open source softwares only. So then we will do a simulation on that, and once a simulation is realized, then how do we actually build the actual hardware, and finally our end goal is to make a PCB. So one final assignment, like one final project, mini project sort of thing, will be there at the end of the course, where you would be asked to for a given circuit, you will be asked to make a schematic and the PCB layout for that circuit and just show us that. We will not be making the actual PCB because our course is online and also but you will still get a feel of PCB design. Okay, this is how we have to do the routing and everything. So yeah, so these are the so these are things. So
Using hello.
yeah, tell me.
Using which software are you trying to do designing PCB?
So here, so for this course, we are only using all open source softwares. So because of that, so we will be focusing on KiCad.
Okay, sir.
Yeah, KiCad is a very good software. So it matches. We have also here in IISc also we have lot of our projects we have made using KiCad only. So KiCad is pretty good software. Yes. Any so that's a rough overview. You can just go through the lectures that are there, just rush through the lectures to get a little more better idea. I would feel that's already uploaded in the YouTube channel. Yeah, any other questions? Do we need to buy additional components? Oh, sorry, this is for log electronics lab, not for mine. Okay. Do any more questions, any more doubts regarding this? Otherwise, okay, then I can wind up then.
Hello, sir.
Yes.
Sir, in this course, the majority part is the practical based or the theoretical based?
So we are okay. So we are you won't be having hands-on like in a lab component won't be there, but it is still practical based because we are talking about designing actual circuits and the complications that come when we design and or like for example how to design an inductor. So these things we will because inductors and all you normally don't get it ready made. So if our circuits have inductors, how do we design an actual inductor? What are the things we need to take care of? And so like that, you will get more exposure about a lot of practical things from this course. And based on the knowledge of this course, it'll be easier for you to now then go and make a circuit. So yeah. Any other question? I think someone is trying to speak, but I am not able to hear their audio. Or no, okay. Also just here, so we are from the Department of Electronic Systems Engineering in IISc Bangalore. So here we have a MTech program that is called MTech in EPD, Electronic Product Design. And so Professor Umanand is the coordinator for that program here. And uh, so the things, so this actually a 2-year MTech program. And so in this course, we have taken many of the things that the MTech students only learned, but not to its fullest depth, because obviously being an online program, we cannot go into that depth, but we have taken a lot of things what the MTech students actually learned here, and we have put it, we have curated it, and thus we have made this course so that most of you who are in your UG level, undergraduate level, will get a very good exposure to what actual circuit design and how to actually make a finished electronic product, and what is the design procedure and all of that. So you will get a good exposure about that at this stage. So yeah, so that is something you can think about. Yeah.
Sir, what is the frequency of the live session per week?
Sorry, can you say again? What is the frequency of the?
live sessions?
So normally we do not uh, normally we keep a live session only once in 2 or 3 weeks. So that time when so our mode of thing is like that as of now. So once in 2 weeks or once in 2 weeks at least, yeah. We once in 2 or 3 weeks we have a live session. But then when we have a group in chats, Google chat. So in that, so the students who have taken this course, though, they regularly ask me questions. So and then I try to clear them in 1 or 2 days. So yeah, we can keep in touch even though okay, live session might not be there, but using Google Chats. So in that, we can make a group. So whoever will join for this course, so we will have a group, and so in that group, all your questions, everything you can type and ask, and I will reply. I'll try to reply it in 1 or 2 days. And normally we also will have some live session just before the exams. So like quiz 1, quiz 2, and your final exam. So just before that, normally we will have live sessions at that time also. Okay, any more questions or
No more question. Thank you very much, Matthew.
okay, yeah, okay. So thank you all.
Rama's session.
Yes, sir.
Yeah. Could you please
Yeah.
give a presentation? Yeah, please.
Yeah. So, hello everyone. I will be giving an introduction to the course Control Engineering. So, topic-wise, if you see, this course is basically a continuation of what you learned in Signals and Systems course. So, a strong foundation in Signals and Systems is very much necessary. Like differential equations, Laplace transform, Fourier transform, impulse response, and all those concepts that you have learned in your signals and systems will be expanded upon. So in your signals and systems, you were given a single system and you were trained how to analyze it mathematically. In control systems, what you will do is you think a little more than that. So here you are given a system and you are asked how to control it, how to make it behave in a certain way you want by cascading it with another system, which is called a controller. So control systems is basically a design of an extra control system that is going together with your original system, so that the system that you have is made to behave in a way that you want. So you will study about the architectures and the types of design that you require to study controllers. So, and it is also the last part of this course, the last 3 weeks or something, will be using linear algebra. So that is also a very important component of this course. So the first 9 weeks will be purely an extension of signals and systems, whereas the last 3 weeks will be expanding on linear algebraic models of systems. So you will be learning what are the design techniques for designing controllers and what is the advantage and disadvantage of each of them. So there are actually 2 design assignments for this course where you will be required to use MATLAB to design controllers and analyze and then verify whether you have designed correctly or not. And then you also have live sessions of 5 hours per week, which is basically 2 hours, 2 hours, and 1 hour. So you have 3 days, 2 days, 2 hour live sessions, and one day, 1 hour live session. So here, the course in charge for this course is Professor Ramkrishna Basumarati from IIT Madras. So his lecture videos will be already given to you. You have to watch them. And in the live sessions, you are expected to ask any questions, and we'll also solve problems. And if you also have a stock of problems with you that you cannot solve, then we will do that also. And we will also be guiding you through MATLAB simulation wherever required, how to implement all the theoretical concepts that you have studied using MATLAB commands, appropriate MATLAB commands. And then you will also finally learn how to design how to model a given system and design a controller from scratch. So apart from that, this course in general is a math heavy course as was signals and systems. So if it would be very helpful if you revise your signals and systems concepts strongly, and also mathematics like differential equations, Laplace transform, and Fourier transform, then it will become very, very easier for you, and you can focus only on the control systems part. You don't need to reread all the old stuff. So that is the main prerequisite for this course. Any questions? Any questions from your side? Okay, then good luck for this course.
Sir, hello.
Yes.
Who will be going to the instructors for these courses?
The course in charge is Professor Ramkrishna Basumarati. I will not be the instructor next time, so I'm just here for the orientation. So you'll be informed soon who the instructor is.
No, means live session. Who will be handling the live sessions?
That's what I'm saying. Vasumati will be handling live will be one of your instructors. The other instructor will be I was the instructor this time, but I will not be for next time. So you will be soon informed who is the second instructor.
Okay.
Any other questions?
No, thank you.
Okay, thank you.
Thank you, sir. Shreyas, no?
Yes. Sure. Okay. Can you hear me? Am I audible?
Yeah.
All right. So I'm here to talk about the computer organization course. So basically, what we'll learn, it'll be handled by Professor Janaki Raman from IIT Madras Electrical Engineering Department. So I was a course instructor for it in the previous offering. I won't be the course instructor for it in the next offering, but I'm here to brief about what will be covered in the course, like in general. So the course will start with it'll be a follow-up to the digital system designs course offered by Professor Nitin. So in this course, we'll be covering the microprocessor aspects of it. So it'll start right from taking a normal C code and trying to understand the fundamentals of how the C code is going to be translated to a machine language and how exactly it is going to be passed to a microprocessor. And following that, we will also try to understand the implementation of microprocessor itself. We'll go from basic building blocks of how we can analyze the timings of it, how we can do the timing analysis for the microprocessor, how we can understand the building blocks, like let's say register file, let's say how there are going to be memory elements which will interact with your actual ALUs, how you'll configure the entire data path itself. So all of that will be covered. And I know the ideas of, let's say, pipelining or multi-cycle implementations will be introduced in the digital systems design course itself, but that will not be introduced for the microprocessor itself. So in this course, we will be looking at actual RISC-V implementation and trying to understand the various aspects of various aspects of the RISC-V processor for single cycle, multi-cycle, and pipeline stages. And we'll also try to understand a bit of the memory architecture itself, memory towards the end of the course. For this course, there'll be there might be one live session per week at max, and yeah, as it was mentioned before, I think there is a Google group through which we can always you can always connect with the course instructor, or professor is also very active. So if required, you can always mail the professor for any doubts. Yeah, I think that's mostly it. If you guys have any questions, please feel free to ask right now. Are there any questions regarding this course?
If you have any question, please unmute and ask. How many of them are diploma levels? So I'm going to do this degree level computer organization. And how many of them have completed diploma level course? Degree level plus. So if you have any question, please raise your queries. Please unmute and ask.
Sir, I want to know the pattern of the quizzes. Is it the subjective or objective type?
In the previous offering, it was a computer-based exam. The quizzes was computer-based, and the exam was, I think, pen and paper. Next offering, professor will decide, but mostly it will be similar.
Sir, in this particular course, is there any use of Linux or only C programming?
So you don't necessarily need to have the knowledge of Linux for doing the course. You don't really need. But if you want to implement something eventually, it could be useful. You don't really need it though. For the course, you don't need Linux. You don't need to know how to use Linux.
Just the prerequisite is PDS and C programming.
Could you please go again?
Sir, in this particular course, only the prerequisite is the C programming and the digital system design.
Yes, exactly. C programming will be assumed to be known. Assembly will be introduced in the course, like x86 assembly language will be introduced in this course. And you will also be pointed to resources where you can learn more about x86 assembly language if you're interested. If you're interested in learning about that. Apart from that, yes, digital system design will be another prerequisite for the course.
And sir, can you please tell us about the preferred books?
For the books, I think first part of the course where I was talking about trying to understand how a C program is, how exactly it is executed in a microprocessor. That part is usually that part there is no explicit explicit textbook that professor follows. In fact, he came up with this this kind of teaching for this kind of course content for that. For the rest of the course, there is a textbook by Professor Harris, Professor David Harris. So I think it's called I think it's called Digital Design, or Digital Design and Computer Architecture. I'm not exactly sure. There's a textbook by Professor David Harris. which is what is going to be followed. The exact textbook, I think the prof will mention it in the course introduction video itself. Are there any other questions?
Okay, Shreyas, thank you very much.
All right, thank you, sir.
Thank you all. Remaining courses, so we'll tell you when they're going to reorganize for the orientation purpose. Victor can send you a mail. Okay, thank you for all patience. Very much.
Sir,
Thank
just
you.
one question, sir. Is there any instructor in this term, the EMFT, Electronics Field and Transition Line? Because
Just
previous
now
time,
we discussed. Okay. Yeah. What is the question? Continue,
because
please.
previous time there is no instructor for the EMFT. So this time will it be any instructor for this course?
Okay, I just, I mean, that particular instructor, I mean, this time we are not organized, but he's not available right now. But Victoria will share you the details about the person who will be the instructor and also the orientation.
Okay, sir.
Yeah, thank you. Okay, thank you. That's